Hello, this is Dr. Oz. In this video, I would like to show you uniform distribution using Excel. So one of the uniform distribution is based rolling a die. Specifically, rolling a die is uniform discrete distribution because there are a limited number of well-defined outcomes, such as getting 1, 2, 3, 4, 5, 6. All right, so let's define the outcomes here for rolling die. Either it can be 1, 2, 3, 4, 5, or 6. Okay, these are well-defined outcomes. That's why this is discrete distribution. And now I can calculate probabilities associated with these. And here, probability of getting 1 is total probability, which is 100% or 1, divided by number of outcomes, since they all have the same probabilities. Right? And I need to lock my blue array because I will use the same as a count when I drag it right. F4, enter. You can see the probability is 16.7%. Okay, for any outcome. We can calculate the average or mean or expected value, they are the same thing, by multiplying the probabilities with their corresponding outcomes and add them up, which we use some product in Excel. Outcomes times their corresponding probabilities and add them up, which is 3.5. That means that if I play this game long enough and record all the outcomes and average them out, it should end up 3.5. All right, so let's make this more fun. What if I play this game, number of trials? What if I play this game, let's say 5 times? And what is the probability that I will get 1 6 or 2 6s or all the way up to 6 6s, or I could get also 0, right? No 6. So let's say these are number of 6s. Outcome 6, or maybe I should say outcome 6 here. All right. So this is, we can calculate these probabilities easily, right? Probability of X number of 6s in 5 trials. So basically what I could do is I can use binomial distribution, for which is going to be my next video, but I would like to illustrate here. So what's the probability of getting 1 6? So to get 6, I know that the probability of getting a 6 is 16.7%, and I want to get 1 time, so power 1, or in other words, power 1. All right, but the other 5 times, the 4 trials, because I have 5 trials overall, one of them I want them to be 6, other 4 I don't want them to be 6. Then the probability of not 6, which is 1 minus probability of 6, will give me probability of not 6. And I would like to have 5 minus 1, which is 4 of them to be not 6. All right. So if you look at this calculation, you will see this is the probability. However, this ignores the fact that I could get 6 in my first round, or second attempt, or third attempt, or fourth, or fifth. So to be able to take into consideration that the order doesn't matter, because in this case, the way we calculate, we assume that we want to have 6 in the first one and the last 4 is not 6. So, but I don't care whether I get 6 in the first attempt, or second trial, or third, or fourth, or fifth. So if I want to count all those possible combinations, please, I will use combinatorics or combination function, Excel combin. So I have 5 trials, comma, and out of 5, I want one of them to be 6, and I don't care the order. All right. So this is how you will calculate the probability of getting 1 6 out of 5 trials, and using basic binomial distribution, which is actually uniform distribution is the origin distribution. However, when we choose number of outcomes out of so many trials, it becomes binomial distribution. And specifically, you can change these probabilities, still it will be binomial distribution. Probabilities don't have to be exactly the same to call binomial distribution in this case. So I will drag this formula right. Let's see what I need to lock. I need to lock number of trials, which are my blue cells. Click on that, press F4, click on this, press F4. And I don't want the red cell to be locked. I want the probabilities to be locked, so purple cell should be F4 and F4. All right, so probability of getting 1/6 out of 5 is 40%. If I drag it right, we can see all the probabilities. Oh, looks like we have a problem here. So let's take a look at what's going on. Oh, of course, because I cannot get sixes out of 5 trials, right? That doesn't make any sense. So, okay, let me just highlight these and drag it here. All right, so if you see when you add them up, the probability adds up to 100%. So probability of getting exactly 3 6s out of 5 attempts is 3%. Probability of getting 4 6s or 5 6s, exactly 4 or 5 6s out of 5 trials, almost 0. If I increase decimals, you can see there is a value, but almost 0. Okay, that's it for this video. Until next video, enjoy business analytics.